discussed in the early classes of this motion, we said the motion of a body with respect to a particular reference is called relative motion. So motion of a body with respect to a particular reference is called relative motion. So now that we've discussed in the early part of the syllabus what we call the reference of frame, we need to understand that when we observe a motion with respect to one another, and we are going to talk about relative motion. And in this case, because we are only considering motion in one dimension, we should keep it in mind that we are talking about linear motion. So we have about 2 to 3 cases I will discuss about under relative motion, which students can always keep in mind. So the first case, I'll call case 1, is a situation whereby we have a body moving in the same direction. So whenever we have two bodies moving in the same direction, let's say we have a body A moving, as you can see, and we also have body B also moving. Both are moving in the same direction as illustrated here. This is body A is moving with a velocity of VA in this direction. Body B is moving with a velocity of VB in also the same direction. So we can say velocity of B relative to A, which we write as VBA, said velocity of B relative to A, because they are in the same direction, is equals to VB minus VA. So students should keep this in mind, because direct application we are going to be considering this formula. I have explained this under reference of frame. We said the velocity of B with respect to A. You can see this body is moving, we consider this to be at rest. So velocity of this one relative to this is called VBA. Velocity of B respect to A will be the distance or the velocity moved by B minus that moved by A. Because as this body is moving, let's say it's moving at the velocity of 1 meter per second towards this direction, this is also what trying to what see the movement. So we say the velocity of this minus that of that. So the second case, which I call case 2, case study 2, is a situation whereby bodies are moving in opposite direction. In this situation, we can also consider the motion of the body along a straight line, because that is what we are considering here. We are doing motion in one dimension, so we should always keep it in mind that we only limit all our applications and what concepts with respect to what we are doing. So in this case, when body is moving in opposite direction, so we have a velocity, let's say the first body is body A, it is moving along this direction. We have this direction, and the second body is moving along this direction. As illustrated, we call this one body B. So here, body B is moving with the velocity of VB, and body A is moving with the velocity of VA. So we can say that the velocity of B relative to A, you can say I take a step to you, you also take a step towards me. As you can see, the total number of steps we take towards each other, the velocity of B relative to A is now equals to VB plus VA. So students should keep this direct formula in mind, because the application is very, very important when solving numerical directly in physics and relative motion. Now, the same thing you can also note, a quick one, you can note. Students should also put this in mind to note that the same principle, you can say same, is also applicable to acceleration. So please, if acceleration of a body is moving in the same direction, we subtract. The relative acceleration is going to be subtraction of the two accelerations of the body, and when they are moving in the same direction, we are going to add. So to understand this very well, let us take a quick example, just one example. before we talk about miscellaneous exercise after the end of the chapter. So the example we are going to consider here is just one, and let's see a simple illustration here. We have a body, we have a diagram. I'm not drawn to scale. We have a diagram like a ground, the body is on ground, and we have a stairs in this form, something like a stairs. I'm trying to draw out the diagrams for understanding's sake. So we have something like that. We have this was taken to be 100 meters according to the question, and this here we have a boy standing on top of this one here. I think he's throwing something, the hand was stretched out in that direction. This will call, we have B here, and in this similar case we have somebody standing on top of the ground, also stretch out his hand and also throw another thing here. This was taken to be 5 meters per second, and this was taken to be 20 meters per second. So the question says, according to the diagram, we don't need to write all those ones. We have according to the diagram, if both boys throw the ball as shown, find the time the ball will collide. Now you can see, as we have discussed, this is a question on relative motion because we need to look at the direction at which the ball is being thrown. Now in this case, you can see the first ball is coming towards this direction, the other one is going towards the opposite direction. As the two bodies are moving in opposite direction, you can say the velocity of what, if this is at rest because it's on ground. I hope students can understand this simple concept from what I have given here. So we can say the body, if this is at ground or is at rest, because we have discussed before in early classes about reference of frame, that reference of frame can be in two cases. It can be at rest and it can be moving. So it all depends. So if this body is at on ground, the velocity of, let's say the first one, the velocity of B, this is the A, the velocity of B relative to A, which we call VBA, already discussed here, they are in what opposite direction, will be what VB plus VA. That is the first thing we need to understand. And if we go by that, this is 20, this is 5. We are going to sum 20 plus 5 in meters per second, give us the relative velocity of the two bodies, which is 20 meters per second. Now, the next thing we need to understand is the acceleration. From what we have discussed also, I said acceleration of body also follow the same thing. Now, if you look at this very closely, this is at rest. This is coming to meet this that is at rest. Now, what you need to understand is that as this is coming downward, the body also here, the second body is at rest, the weight or the acceleration of gravity is also downward. So if you look at that, you can say the relative acceleration as well, acceleration of B relative to A from what I have said, because they are now in the same direction. So with the what? With the, we are talking about gravity, will be G minus G. So we can say the body is now accelerating is equals to 0, which temporarily you might not even put it in the calculation. Remember, the question asks us the time at which the ball will collide. From our normal distance time formula, you know that velocity of a body, so relative velocity or velocity is taken as distance moved divided by time. So a direct solution from here will give us nothing but making time subject of formula. We take the velocity, will be equals to the time by the subject of formula here will give us distance divided by velocity. I hope students were able to understand this. So here the distance taken by the two bodies was what they are separated by a distance of 100 meters. So if we take that 100 divided by the velocity of what? Relative velocity of B with respect to A, which was given as 25 from our calculation, will give us nothing but 4 seconds, which will be the time the two bodies or the two balls will collide somewhere around this position. So guys, this is where I will